I am going to talk of growth of current in LR circuit. So what is basically LR? We have a solenoid like this. We have a resistance like this. So let's say the self inductance of this coil is L, and we have a voltage supply of say EMF E. So what we want to do is we want to see that how the current will increase. Is it like IR? Does it just if you put a battery in this resistance, does it immediately go to IR current, or does it take some time to go? And when we put a inductor, does it immediately go to IR, or does it take some finite amount of time to go to IR value, or does it even go, or does it take infinite time to go to that level? So we need to see. So when you put the inductor along with the resistance, the current uh, achieve its maximum value, which is equal to IR, in a very long time, and that long time is in comparison to when no inductor is present. Say EMF is there, so according to this battery, this will throw the current, and current will start flowing this. And we know that as the current moves through the coil, and if the current is changing uh, in the coil, we have discussed that EMF induced is minus L di by dt, where I is increasing, where I is increasing. So we can we instead of inductor, there will be induced voltage across this, and that voltage will be equal to, you can put a battery like this. So this is the resistance. Instead of inductor, now we have put certain this induced voltage, which is equal to L di by dt, which its magnitude, and this is EMF. Now if you use the loop law for the current, so if you move from this to this, plus to negative, there is a drop, so it is plus E, and the current flow direction is this, so this and this. So we are moving from here to here, okay. Then we are going in opposite direction of this current, so it will be minus IR, and then negative to positive we are going, so it will be negative of L di by dt, which is basically a magnitude, is equal to 0. So this is equal to E minus IR is equal to L di by dt. This will be equal to L by dt is equal to di over E minus IR. This will make be equal to, this is L dt, no, this is 1 over L dt. So 1 over L dt integration is equal to integration of di over E minus IR. So this will become 1 over L times T is equal to minus 1 over R ln exponent E minus IR over E. If you solve this equation, this will be equal to I is equal to E by R 1 minus exponential minus RT by L. So this is basically I is equal to E by R 1 minus exponential minus R minus T over some constant tau, where tau is equal to basically L by R, which is basically called time constant of this circuit. So we see if time is 0, it is E by R initially. If the time is 0, as the time moves on, no, sorry, so at time is equal to 0, it will be not E by R, it is E by R 1 minus exponential 0. This will be 1 minus 1, which is 0. So at time t is equal to 0, it is 0. At time t is equal to infinity, when I will be equal to E by R 1 minus exponential minus infinity. Exponential minus infinity is 0, so it will become E by R. So at time t infinity, after a long time, it will become the current will become E by R. So if there was no inductor, it would be E by R immediately. But if you have an inductor along with the resistance, then it takes a finite, a very long time, maybe many time constants to achieve at least 99% of E by R value. So basically the curve of this is like this, where the maximum value is E by R, which is current, and initial value is 0, and this is time. So this is, say, 1 time constant, 2 time constant, 3 time constant. In 1 time constant you achieve at least 63% of the total current, which you can calculate from here. If you put t is equal to 1 tau, you can calculate this value, and then you can see that 63 in 1 time constant you achieve 63% of the total current. So that's all for this video. Thank you. So thanks for watching this video. If you have any questions, you can put below and I will try to solve those problems for you. You can just put the number of problem number, or if you want to solve, get it solved, or you want to understand any concept in physics, you can basically just comment it down, and you can like, share and subscribe. Thank you.